Hi everybody. So in today's video, we are going to continue talking about position, velocity, acceleration, but what we're going to focus on is how do you analyze those three ideas when you are given the graph of velocity. Now I want you to think about this as being very similar, and you're going to notice a lot of the ideas are very similar to when we are given the graph of f prime, which is a topic that we covered in our chapter 5 unit. So what we've given here is the graph of the velocity, and we are going to be asked to answer the following questions using that graph. So what we'll do is we'll talk about what do you look for, and then do an example problem for each one. For example, if you are trying to find instantaneous velocity, and you've been given the graph of velocity, then all that you're going to look at is the y values of the graph. Now, the reason for that is if this is the graph of velocity, then the y values are the velocity. So for example, if it says, what is Waldo's velocity at t equals 14? I would go to where the time is 14, I would find that point, and I would match that up with the y value, which is 3. Now it says that this is being measured in feet per second, so I would say 3 feet per second. If we are asked to determine whether, in this case, Waldo is moving to the right or moving to the left, we have to look at two different things on the graph. Moving to the right is the same thing as saying that your velocity is greater than or equal to 0. In other words, this is where the graph is above the x-axis. So for example, I would be moving to the right on this section of the graph, during this section of the graph. And so I would list my time intervals as from 0 to 3, and then also from 9 to 19. If I'm asked to determine when we are moving to the left, or backwards, or down, or just in a negative direction, moving to the left would be when your velocity is less than or equal to 0, which means you're looking for where your graph is below the x-axis. So that would be this section of the graph and this little section of the graph here. So I would say that that would be between 3 and 9, and then also from 19 to 20 seconds. Now we know from our previous investigation of speed that speed is always the absolute value of velocity. So what we would do is we would find the y value on the graph, just like we were finding velocity, but we would just make it positive regardless of whether it was negative or positive to begin with. So if I say what is Waldo's speed at t equals 5, t equals 5 would be right here. I would normally say that the velocity is negative 3. But because I want speed, I'm going to do the absolute value of negative 3, which is positive 3 feet per second. Now acceleration is the derivative of velocity. In other words, this is the slope of the graph of velocity. So if I say, what is Waldo's acceleration at t equals 1, t equals 1 is right here, and this section of the graph has a slope of negative 1, because to go from here to here, you would go down 3 over 3, so the slope would be negative 1. Now my units here, my pen is dying a little bit, golly. So my units here would be negative 1 feet per second squared. Finally, we are sometimes asked to look at whether our speed is increasing or our speed is decreasing. Speed increasing means both velocity and acceleration have the same signs. So we want our velocity to be positive and acceleration to be positive, or velocity to be negative and acceleration to be negative. Now there are two situations where this can happen. You could be above which means your velocity is positive, and have a positive slope, so uphill, that would be your acceleration being positive. So above and uphill means that both are positive. Or you could be below and downhill, meaning your velocity is negative and your acceleration is negative. So if I look for that, for increasing above and uphill or below and downhill, I'm above and uphill here, and I'm below and downhill here and here. So I would say my speed is increasing between 3 and 4, between 9 and 12, and between 19 and 20. Now conversely, for decreasing, we want velocity and acceleration to have opposite signs. Again, there are two situations that can make this happen. We could be above but be going downhill, which means velocity is positive but acceleration is negative. Or we could be below and be going uphill, which means velocity is negative and acceleration is positive. On this graph, that would be above and downhill is right here, and right here. Below and uphill is right here. So I would list the intervals from 0 to 3, from 6 to 9, from 15 to 17, and from 18 to 19. So let's go through one example together so you can kind of see how this is going to work. So in the next figure, we are looking at the graph of velocity, and it says, when does the particle move forward, backward, speed up, and slow down? Let's start with forward. The particle is going to move forward when your velocity is positive. So we would say that forward is anytime we're above the x-axis, which in this case would be from 0 to 30 minutes. Backward is whenever your velocity is less than or equal to 0, which in this case would be from 30 to 55 minutes, because that's where we're below the x-axis. Speeding up would mean above and uphill or below and downhill. So above and uphill would be from 0 to 10. And below and downhill would be from 30 to 40. Slowing down would be when velocity and acceleration have opposite signs. So above and downhill, which would be from 15 to 30, or below and uphill, which would be from 40 to 55, because they would have opposite signs. If I want to know just strictly when is the acceleration positive, acceleration is going to be the slope of the graph that we're looking at, the slope of this velocity graph. So positive would be when the slope is positive, which would be from 0 to 10, and then also from 40 to 55. My acceleration is going to be negative whenever my slope is downhill, so negative. So I would say from 15 to 40. And my acceleration is going to be 0 whenever my slope is 0, which only happens here from 10 to 15. When is the particle moving at its greatest speed? Now, since speed is the absolute value of velocity, I'm looking for the biggest y value, but it could be positive or negative. It looks like the biggest y value here is 60 because the lowest it goes would be 40, negative 40, and that happens between 10 and 15. When does the particle reverse directions? Well, remember, whenever we're above, we're going to the right, and below, we're going to the left. So we change directions when we cross over, which would be at t equals 30. And finally, approximately when is the particle moving at a constant speed? A constant speed means that the velocity stays constant. In other words, we're looking for horizontal lines on the graph. So that would again be between 10 and 15. Now that should make sense because if we're not accelerating, here, if we're not accelerating, our acceleration is 0, then it makes sense that we have a constant speed. We're not changing our speed because our acceleration is our change in our speed. All right, that's it. Thank you guys so much for watching, and I will see you for some practice.